Hello students, myself Tejaswini, lecturer in ENC, SJ Government Polytechnic, Bangalore. Today it is the fifth session of Unit 1, Introduction and Architecture of PLC. Today we are going to discuss about in detail the architecture of PLC. Before starting the session, let us have a small recap on the previous sessions. Okay. We have already seen what is the definition of PLC and what are the main components of the PLC. Okay, do you remember the definition of PLC? In brief, PLC it is a programmable device. PLC is a programmable device which is used to control the industrial environment, or PLC is a specialized computer. It is designed to control the process of industrial automation. Okay. And next we have seen the major components of the PLC. Okay. And then again we have seen the classification of the PLCs. The classification of the PLCs, we have we have seen different types of PLCs. We have seen modular PLC as well as compact PLC. What is modular PLC? The modular PLC, it will permits to allow the extension of the modules. In the module, all the components are independent to each other. We can add on how many modules we want. So we all connect all the components to form a PLC system. Okay. And next in the compact PLC, what we will do? In the compact PLC, all the modules, that is CPU, IO unit, power supply, all are in the single case. All are embedded in the single case. Here everything, the input, IO units and all, everything is decided by your manufacturer. Okay. It is also known as fixed PLC or integrated PLC. Okay. Then again we classified the PLCs based on IO systems and application ranges. In the IO systems, we have seen the digital IO system and then analog IO system. For discrete or digital signals, we'll be using the digital IO systems, and for analog continuous signals, we'll be using the continuous IO systems. Okay. And next, based on application ranges, we have seen the nano and pico PLCs, then micro PLCs, small PLCs, large PLCs, medium PLCs and very large PLCs. See, all the applications, because whatever the applications we are having, they are not of same type. Okay, we'll be having the bigger applications as well as the smaller applications. Based on how many inputs and outputs we need, we select the PLCs. Okay. Then after that, we have seen the difference between relay logic control and PLC logic control. We have seen what is relay logic and what is PLC logic. Relay logic, in that relay logic is nothing but it is a network of wiring of components in the relay logic. The main disadvantage in the relay logic is the elaborate wiring system. But in case of PLC, everything is done in the system. Okay. So that is why today in every industries they are preferring to go for PLCs. Okay. And in the relays, okay. Now after the comparison between the relay logic as well as the PLC logic, we have seen some of the advantages and disadvantages of the PLC. What are the advantages of the PLC? First one, if you remember, the first one is flexibility, implementing and changing and correcting errors, then low cost, speed operation, then pilot running, visual observation, documentation, then ladder programming method, security, etc. These are some of the advantages of the PLC. And if you list the disadvantages of the PLC, fixed program applications, then newer technology, then environmental considerations, fail-safe operations, etc. These are some of the disadvantages of the PLC. But the advantages are more of the PLC compared to your disadvantages. Okay, so that is why even though the PLCs and relay logics, they both do the same logical computation, today they are preferring PLCs. Okay, this is the small recap of the previous sessions. Today we will start our lecture with internal architecture of PLC. Okay, already we have seen the major components. Here we will discuss little bit in detail. Okay. Next, this is the block diagram of PLC. In the block diagram, see if you see that the important components are input module and output module, then CPU, central processing unit with memory, then you are having the power supply, then you are having the programming device. This is the block diagram of the PLC. If you go for, this is your internal architecture of the PLC, how it looks like. Okay. See, if you see here, our main components, this is our CPU. Okay. And this is RAM, ROM and all, this is the memory unit. And this is our IO module unit. Okay. And next from here, we are giving the input channels, and from here we are controlling our actuators. This is the output channels. And to communicate all these components, we need the buses. Okay, here we are having 4 types of buses we are used. Okay, see, generally in the PLC what happens, the inputs are continuously monitored and the status of the terminal is copied from the input module and it is given to the RAM memory. And again it is divided into 2 sections. One is input image file and the other one is output image file. Each input and output module is associated with a single bit of input image file and output image file. Okay. Then what the CPU does is, the CPU, it fetches the input variable from the input image file, and depending on the program and status of the input, the output image file is filled by the CPU. Okay. Then with control variable, which are then copied into the output modules for controlling the operations. Okay. This is how it works. Okay. And next, what are the main components of the PLCs? The main parts of a PLC are divided into input-output section, central processing unit, buses, memory, power supply, programming device, racks and chassis. These are main parts of the PLCs. The PLCs follows closed architecture. So, one must be sure that any generic hardware or software we may use, it should be compatible with our PLCs. Okay. PLC programs, they cannot be interchanged among different PLC manufacturers. Okay. Now we will see each component one by one. Okay. First one is CPU. What is CPU? Central processing unit. What it does? The internal structure of the CPU, it depends on the microprocessor concerned. So in general, they have arithmetic and logic unit. What this ALU does? It is responsible for data manipulations and carrying out the arithmetic operations like addition, subtractions, etc. And even logical operation, that is AND operation, OR operation, NOT operation, XOR operation, etc. So it performs the arithmetical and logical operations. Then memory, termed registers located within the microprocessor and used to store the information that is involved in the program execution. Okay. And a control unit, which is used to control the timing of operation. This is also very important. Okay. See, if you see in the internal architecture, here CPU, it is provided with a clock. Why clock is needed? because if you want to synchronize your operations, the clock plays a very important role. Understood? The clock will be giving around the frequency of 1 to 8 megahertz frequency. Okay, to synchronize the operations, clock plays a very important role. Okay, next one is bus. What is a bus? Buses are the paths which are used for communication within the PLCs. The information through these buses are transmitted in the form of binary, that is zeros and ones. Okay. If you see in the internal architecture, see here we can see the 4 types of buses: address bus, control bus, data bus and system bus. Okay, now we will see in detail. The system has 4 buses. First one is data bus. What is data bus? Data bus, it carries the data used in the processing carried out by the CPU. This bus carries the data, whatever it is done by the CPU. Understood? And data bus is a bidirectional bus. It is a two-way bus. And next one is the address bus. What is address bus? It is used to carry the addresses of memory locations. Okay, so that each word can be located in the memory. And for every memory location, it will be given with a unique address. Understood? If it is an 8-bit processor, that means it will be having 2 power 8. 16 means 2 power 16 memory location, that is address locations. Next one is the control bus. What is control bus? Control bus, it carries the signals used by the CPU for controlling various operations. Okay. And in the control bus, the signals inform the memory devices whether they receive data from the input devices or it is to send the data. Okay. Then the control bus, it also carries the timing signals for synchronization of the operations. Next one is the system bus. System bus is used for communication between the input or output ports and the input or output unit. The system bus we are using to communicate between the I/O modules. Okay. Next one is the memory. What is memory here? Why we are using the memory here? Memory here we are using this to store our ladder programs. Whatever the programs were to store that, we are using the memory. And also to store the input output devices information and the preset values of the timers, counters, everything that will be stored in the memory. And we are having different types of solid state memories: ROM, RAM, EEPROM, EEPROM, NOV RAM. Okay, we are having different types of memories here. ROM. ROM is read-only memory. It is the permanent storage for the operating system and fixed data is used by the CPU. And next one is the RAM, random access memory. This we are using for storing the user's program and also for storing the data. Understood? This is about the memory. And next one is input output unit. So the input output unit, it provides the interface between the system and the outside world, that is the real world. It provides the interface between your PLC and the real world, allowing for connections to be made through input output channels to input devices. Input devices as sensing devices, that is sensors and switches. These are all the input devices. And output devices. Output devices are motors, solenoids. These are all output devices. The input/output channels provide isolation and signal conditioning functions so that Sensors and actuators can often be directly connected to them without the need of a external circuitry. See here, it provides an electrical isolation. How it provides the electrical isolation? By using the opto-isolator or opto-coupler. See, in the what happen in the opto-isolator is we are having the two components, that is your LED light emitting diode and the phototransistor. Whenever a digital pulse whenever a digital pulse reaches the LED, what happens? A infrared radiation pulse is produced. That is detected by your photodiode. And when the photodiode detects this radiation, a digital output pulse is produced. Okay. So here between the LED and the phototransistor, there is a gap. That gap we are calling it as a electrical isolation. That we will study in detail in the next coming sessions. Okay. So the input output channels it provide isolation and signal conditioning functions. Okay. Next one is programming device. So what is this programming device? Programming devices are dedicated devices used for loading the user program into the program memory or edit it and to monitor the execution of the program of the PLC. So if you want to do programming, some engineer or technical person should be there to enter your program, to run your program. So how you are entering that program? Okay, we are having some programming devices like handheld terminal. We are having dedicated terminal and your PCs, that is your personal computers. These are the programming devices. From these we are entering our program into the system. It is also used to troubleshoot the PLC ladder logic program. After entering, we can check, we can test the program, we can edit it, we can reprogram it, whatever we want by using the programming device. Understood? And next one is the power supply. Power supply is the important thing. PLC, it has two power supply sections. One is your internal power supply and the other one is the external power supply. Internal power supply. Internal power supply, it provides supply to the CPU module which requires plus 5 volt and minus 5 volt DC supply. For the CPU, the power supply should in between minus 5 volt to the plus 5 volt. Okay. And then we are having external power supply. External power supply, it provides supply to the IO modules. Okay. And in this section, you may require plus 5 volt, plus 24 volt, plus 120 volt DC supply as well as AC supply. If we see the internal architecture of the PLC diagram, see here, this is the input channels. See here, this is the external power supply. Here we can have plus 5 volt, plus 10 volt, plus 12 volt, 24 volt, 120 volt, etc. And even output channels. Here also we can have plus 5 volt, 24, 120 volts voltage. But to the CPU, from input channels to the CPU, it should be between plus 5 to minus 5 volt, and from CPU to the output module, it should be between plus 5 volt to minus 5 volt. If it is more than that, it will damage the processing unit. Understood? This is about the power supply. And see, for the CPU, it should be DC only. But the external power supply to the IO module, it may be AC or it may be DC supply. And next one is racks and chassis. The racks on which the PLC parts are mounted and the enclosures on which the CPU, program monitor and IO modules are mounted. It is the rack is nothing but all the components are mounted on the racks. Okay, it is called as racks and chassis. Understood? So, if we'll have a brief summary on today's session. See, we have studied the internal architecture of PLC. First, we have seen the central processing unit. It performs the arithmetic, logical operations, and then next we have seen the after CPU, we have seen the memory. We are having different types of memory, not only ROM and RAM, EEPROM, EEPROM, VRAM, etc. And in this, ROM is permanent memory, and RAM is the temporary memory where we write the programs and store the data. Okay, and then we have seen the buses. We are having 4 types of buses: data bus, address bus, control bus, and system bus. Then we have seen the I/O module unit, input and output module unit. Then power supply. We'll be having 2 power supplies, in internal power supply and external power supplies. Then programming devices. The programming devices, we are having handheld terminals, dedicated terminals, and your personal computers. Then racks and chassis. These are some of the major components of the PLC. Now let us solve some multiple choice questions based on this topic. First one, which architectural unit or block of PLC decides the sequence of different operations to be executed by means of instruction written in memory? Once again, I'll read the question. Which architectural block of PLC decides the sequence of different operations to be executed by means of instructions written in memory? Option A, memory. Option B, programming software. Option C, I/O interface. Option D, CPU. The answer is CPU, Central Processing Unit. Next one. In addition to storage instruction, PLC controls dash logic sequence timing, counting, arithmetic operations, all of the above. You already know that PLC, it performs logic sequence timing, counting, and arithmetic operations. So, the answer is all of the above. Dash considered as the brain of the PLC unit. Power supply, I/O module, CPU module, none of this. Which is the brain of the PLC unit? It is your CPU module, Central Processing Unit module. The part that monitors the inputs and makes decisions in the PLC is the CPU. True, false, none of the above. It monitors the input and makes decisions in the PLC. It is true. It is done by the CPU. Next, the buses are the dash used for communication within the PLC. The buses are the paths used for communication within the PLC. The communication is done between all the components by using the buses. Understood? Okay. I hope you understood this session, and thank you for listening.